Dear students and participants of the course on railway engineering, today we are going to shift our focus now. The discussion so far which we have done was on joints in the previous maybe around 2 or 3 lectures, but now we are shifting to SWR rails. SWR means this is short welded rail. In one other form you can say that because we were discussing about the welded rails in the previous lectures, so it is just a continuation of that. So, in the previous lecture we talked about the flush butt welded joints, and before that we also discussed about the various precautions which needs to be taken if we are having a AT weld joint, that is aluminothermite weld joint. Now, today when we will be taking up the short welded rails, then the points which we are going to discuss, they are components, the laying of SWR, gap service which needs to be done, what type of maintenances are required, and what are the do's and don'ts when we are working with SWR for the staff who is going to take care of these type of tracks. Starting with the short welded rails. Now, short welded rail is a combination of 3 rails, and these 3 rails they are welded together, and when they weld together they will be 39 meter long. So, this is for a broad gauge, because there we are considering the rail length of 13 meters. So, these 3 lengths which are used, they are going to be welded here at these gaps, and that is how our SWR will be formed. Now, this SWR, this contracts and expands throughout its length. That means, as soon as there is a temperature difference, this temperature difference based on whether it is positive or negative, it will cause the expansion or it will cause the contraction of this SWR track, and this is going to be in between the joint which is placed here as well as the joint placed here. And this joint can be, even say you can have it a fish plated joint also, but here when you are talking about this SWR which is 3 panels being taken together, all of this length is going to either expand or going to contract. Another thing is this SWR shall be laid generally on a stable and efficiently drained formation. So, formation level is also an important aspect. It should be non-yielding, stable, and the drainage is also an important criteria here. So, drainage should be good, so that water which is going down into the layers which are provided above the formation. So, we have the ballast, and at the top of the ballast and sleepers and rails, those things are being placed. So, if water is seeping inside here, then this will create a problem in this area, and that problem may get translated towards the top. The minimum section of the rail which can be taken in the case of a broad gauge is 90 R. So, it means 90 R and above, say 52 kg per meter or 60 kg per meter, or maybe above that, those are the rail sections which can be used. Majorly they will be falling in this category only. Then the sleepers for use with SWR, they are wooden sleepers with anti-creep or elastic fastenings. It can be cast iron sleeper or it can be a steel sleeper with key type or elastic fastenings, or otherwise it can also be a concrete sleeper. It means in the case of SWR, we can use all variety of sleepers which are available to us, starting from the wooden to CI to steel and then to the concrete, which is the emphasis nowadays. But when we are using these particular sleepers, we need to be careful about the types of fastenings which are required so as to connect the rail with the sleeper. And as you can see that there can be some specific fastenings which will be required, but along with that the elastic fastening is one word which is coming and repeating. So, these elastic fastenings are uh, the fastenings which have been used by Indian Railways from some, maybe you can say years like 10 or 20 years now from backside. So, there is a applicability of SWR with different type of sleepers, and along with sleepers then you have to find out what type of a fastening has to be used. Now, coming to the sleeper spacing. Now, this sleeper spacing is going to be dependent on the sleeper density, and here we are taking an example of a sleeper density of m plus 4, where m is the rail length. So, if this is the sleeper density being used, then either for a metal or a concrete sleeper, but depending on the type of the weld which is being employed for making this SWR panels. So, we can have a flash butt or we can have aluminothermite weld being used. In these cases, you can find here that there are different type of spacings being given, the joint spacing, the shoulder sleeper spacing, then the shoulder which is sleepers which are adjacent to the shoulders, and then the intermediate sleepers. If you remember, then these are the things which we have discussed previously. So, there is a rail section, and at this rail section this is the rail end, and obviously here there will be another rail section. So, a sleeper is provided at this point, then there will be another sleeper, then the other sleepers are provided likewise. This is all dependent on the sleeper density. So, this sleeper at the first one from the rail end is a joint sleeper, and then adjacent to that is the shoulder sleeper, and then the next one again adjacent to the shoulder sleeper, and finally the intermediate sleepers will be provided. So, the spacings have been defined for those different sleepers. So, what it says that the joint spacing is 190. So, this is the 190 is from the center of this to this. So, that is the spacing being defined. Then between shoulder sleeper spacings which are given are like this is 620. So, 190, 620. So, if I say this is A, so we have A here, then B, then there is C, and then finally D onwards. So, the C value can come here and D here, and it says that there are going to be 46 such sleepers being provided which are termed as intermediate sleeper. The change is there in any of the form. So, change comes here basically 1, and instead of 620 which is the shoulder sleeper spacing, we are considering 625 when the AT weld is used. Similarly, adjacent to shoulder in FB it is 730, but when you are using AT then it is 760. The number of sleepers they remains the same, and the intermediate sleepers spacing also remains the same. Now, coming to the another sleeper density, that is m plus 7. So, in the case of m plus 7, again for the type of the weld. So, this is being defined for the same joint sleeper, shoulder sleeper, adjacent to shoulder, and intermediate sleeper. So, here the joint sleeper they are constant as 190 mm, then the shoulder sleeper spacing this is 563 in the case of FB weld and 575 for AT weld. Adjacent to the shoulder sleeper it is 580 and then it is 600 in FB or AT weld respectively. The number of sleepers which are used, because now it is m plus 7, it has increased. So, it is 55 now, and the intermediate sleepers, they have been placed at the same spacing of 660 mm. So, depending on the sleeper density, the number of sleepers will be decided, and then with respect to the joint sleeper and shoulder sleeper adjacent to that and intermediate, those distances or the spacings will be defined. So, they are enumerated or they are very clearly written in the Indian Railways guidelines. Now, to facilitate the on track tamping, which is a part of the maintenance also, which is a part of making a new track also, it is desirable to have continuous stretches with uniform sleeper spacing. And specifically when we are working with the equipment, tamping machine, then in that case if the uniform sleeper spacing has been provided, then that helps a lot. Another thing, the sleeper spacing at joint is from the center of the joint to the center of the joint sleeper. So, that I have already enumerated in the diagram which I made in the previous slides. Now, what are the assumption which is made for the sleeper spacing here? First one, the length of the unwelded rail is 13,000 mm, or we simply say as 13 meters when we are talking about a broad gauge. So, this is our length, and that is why when we talked about SWR, which is a 3 panel system, then that came out to be 39 meter. Then reduction in length of the rail at FB or gas pressure welded joint, that is 20 mm. Here this is a flash butt or the gas pressure welded joint is being created. So, that reduction in the length which is there is 20 mm, and gap to be provided at joint prior to welding, if we are using the AT process, then that gap is 12 mm, because then you have the material which is to be placed, and then the welding material is also going to be there. So, there is a difference between the two, one weld is FB, another is AT. So, in FB it is 20 mm, whereas in the that is the reduction which comes, and in the case of AT it is 12 mm. Minimum sleeper spacing except at fish plated joint, that is 560 mm. So, this minimum value is also being defined here. Now, apart from the sleepers, the ballast is going to be placed below that, so that the sleepers can be kept in position. So, minimum ballast cushion below the bottom of the sleeper is 200 mm for the broad gauge. So, we are talking about a sleeper being provided. So, whatever type of sleeper is there, then the ballast cushion which we are considering here at the bottom, this is what we are saying 200 mm. 100 mm extra width is to be provided to the shoulder ballast over and above the standard ballast section on tangent tracks, and it shall be provided on outside of the curves up to 875 meter radius. So, now we are talking about a curved section. Now, again if you remember when we talked about the permanent way, and a section has been shown like this, and the sleepers were provided, and then the top of that the rails were there. So, there we talked about the cess, and in that cess we said that if it is a curved section, then on the outer side the cess distance which we are considering here, say d, will be increased by certain amount, and those conditions were given there. So, in that line itself what it says that 100 mm extra width of the shoulder ballast over and above the standard ballast section which is being provided on the tangent track shall be provided on outside of the curve if the curve radius is up to 875 meters. So, this is one extra thing which will be there. Similarly, the extra width shall be increased to 150 mm if the curve is 2 degrees or sharper on the broad gauge. So, one is related with the value of R, another is related with the value of degree of curve. So, for these two cases, in one case it is increasing by 100 mm, another case it is increasing by 150 mm. And for SWR, which is laid with 60 kg rails, the ballast profile shall be as prescribed for LWR track. Usually we are working with 90 R and 52 kg per meter rail sections, but if 60 kg per meter rail section is being used in SWR, then the track detailing will be done which suits to LWR. Because tomorrow, then if we have already gone for a 60 kg rail, then this can be upgraded to LWR. So, if that upgradation is required, then we cannot remove the whole of the track and then redo the everything and then place the rails and operate the trains. So, it is better to adopt the LWR track. Now, talking about the laying, the SWR on the PSC sleeper, the concrete sleepers, shall not be laid on curves sharper than 440 meter radius. So, this is one sort of a restriction. If the radius is less than 440 meters, then on the top of PSC sleepers, this SWR will not come. You have to use in that case some other sleeper, and that is again I reiterate that we said that yes, we have moved from wooden to CI and steel, then finally to concrete, but there are certain conditions in which the composite sleepers are going to be used. That means the two different type of sleepers made of different material can also be used. Now, this SWR butting against insulated joints, heel of crossing and stock rail joints, they shall be anchored for a length of 39 meters on the approach effectively to arrest the creep in either direction. So, this is one another aspect. When we will be discussing about the creep, at that time we will understand that what this creep is and how it is being arrested or how it is being controlled in a track. But in this case what it says that if the SWR is butting against any of the insulated joints or where the crossing or the stock rail joints are there. So, this we are going to discuss when we will be talking about the crossing of the two tracks. So, in that case anchoring is to be used, and this anchoring is done for a length of 39 meters on the approach effectively to arrest the creep in either direction, and 39 meters is basically an SWR length which is being used. So, one SWR panel length is going to be anchored on either side. The short welded panel may be continued through the level crossing, but avoiding the fish plated joints on the level crossing and within 6 meter from the end of the level crossing. So, this is another aspect to be taken care of. Then the SWR may be continued over the girder bridges. Here also it is being allowed with unballasted decks, because you are on the girder bridges. So, unballasted decks will be there, but up to 13.3 meter opening if the length of SWR is symmetrical to the center line of the bridge, and up to 6.1 meter opening if the length of the SWR is unsymmetrical to the center line of the bridge. So, that is you have a bridge at this position and SWR is being provided. So, if SWR is only here, so this is not a symmetrical condition. If there is only one track, then there can be symmetrical condition. Say if there are two SWR tracks being provided, so again it is a symmetrical condition which comes. So, looking at the conditions, then these values have been given that whether up to 13.3 meter or 6.1 opening, this has to be done, and the center line of the bridge is being considered here. Now, no fish plated joint should be located on the girder or within 6 meter from either abutment. So, if in plan if we say that there is an abutment here or in the elevation we are talking, so this is an abutment being provided with respect to the location of this bridge, then within 6 meters on this side or other side, no fish plated joint should be located. So, this is another aspect, and we have discussed this aspect previously too. In all such cases, rail free fastenings such as rail free clips shall be used, so that the relative movement between the rail and the sleepers may take place. So, whatever the connection being provided between the rails and the sleeper, then that connection here we are talking in terms of a rail free fastening. So, this connection or the connection in terms of the clip being provided, that is a rail free fastening we are discussing here. And these rail free fastenings, this will allow the relative movement, otherwise it will remain fixed and there will not be a relative movement as such. The gaps which are to be provided for the SWR at the time of laying depends on the installation temperature Ti. I is for installation, and the zone in which the rails are laid. So, there are 4 zones based on the temperature from 1, 2, 3 and 4. So, these 4 zones are there. So, we are talking about the installation temperature, that is the temperature at which the rails have been installed, if with respect to the air temperatures and with respect to the stress free temperatures which otherwise can be there in the rails. Now, this installation temperature Ti, it is the average rail temperature during the process of fastening the rails to the sleepers at the time of installation of SWR. So, it is clearly defined here that what exactly is Ti. But then when, because this fastening work is going on, it may be started in the morning and then going up to late evening also, then whatever the temperature has been there, whatever the variations has been there, on the basis of that, that average rail temperature is to be calculated. So, there are different ways in which the rail temperatures are measured, 3 or 4 such ways are there. Again we will be discussing, talking about those measurement techniques of the rail temperature afterwards. Now, in the case of zone 1 and 2, the installation temperature is used as Ti. But if we are in the zone 3 and 4, based on, again as I said, these zone 1, 2, 3, 4, they are related with certain temperature ranges. So, these temperature ranges we will be again looking as we further go down with our discussion. So, here in the case of zone 3 and zone 4, the installation temperature is taken as 5 degrees centigrade extra with respect to the actual average rail temperature at a time when the installation is going on. So, that is Ti. So, Ti plus 5 degrees centigrade is the value which will be there. Now, in this particular slide, we are giving you the values with respect to the temperature and the gap. So, here the installation of the rails is being talked for different rail temperatures, where the values have been given as Tm minus 17.5 degree to minus 12.6 degree centigrades, and then similarly in the rest of the cases the values are changing and the temperature is increasing in this direction. Now, this Tm is the mean average mean temperature of the rail sections. Now, in the case of zone 1 and 2, if we are using a 39 meter panel or we are using a 26 meter rolled rails, that means they have been manufactured directly into the in the company, in the industry. So, 39 meter panel means this is a combination 13 meter plus 13 meter plus 13 meter. So, it can be SWR in that form. For those, the initial gaps are defined here in mm. The first value is related to the 39 meter panel and the second value is related to 26 meter rolled rail section. So, here what we can see is that as the temperature is increasing, that initial gap which is required is lesser. We started with 12 mm and then we ended here with 2 mm only. Similarly, in the case of zone 3 and zone 4, where either the 39 meter panel or the 26 meter rolled rail sections has been used, for the different rail temperatures here being stated as range from minus 22.5 to 17.6, it means we are going one range below this part, the range which is being used in zone 1 and 2. And then we are coming to the top here, highest values, which again is a one range lower. So, this is the value 2.6 to 7.5, which has been used there in the previous table in the second last column. For those values, the initial gaps again have been defined, but the gaps remains the same as such as they have been used in the case of zone 1 and 2. The only thing is the temperature variations or the ranges of the temperature variations, they are different. Similarly, in the case of during service, what happens? So, in the during service, again the rail temperatures, they have been taken from minus 17.5 degree centigrade to minus 12.6 degree centigrade and 7.6 to 12.5 degree centigrades. That is the range which is being used, the same as we have seen in the case of installation time. And again here for the zone 1 and 2, for 39 meter panel or 26 meter rails, the initial gaps have been defined. Now, here they have been defined in terms of the ranges. If you remember, in the previous one they were in terms of an absolute value, either 12 or either 10. But what we are talking here is 11 to 14. So, for a 39 meter panel, if the temperature is like minus 17.5 to minus 12.6 degree centigrade as a mean rail temperature, then the initial gap is 11 to 14, whereas for 26 meter rolled section it is 8 to 13. And when you come to the highest category where the temperatures are now plus 7.6 to 12.5, there the values ranges from 1.5 in the case of 39 meter panel as well as in the case of 26 meter rolled section. Now, if we shift from 1 and 2 to zone 3 and 4, for the same two conditions of the two types of the rail sections which can be there as 39 meters and 26 meters. Again, for the given temperature ranges which goes one down, if you see here as well as here, then the initial gap in mm that is specified, and that initial gap in mm is again the same as being used above. So, the initial gap values are not changing, the length of the panel is not changing, only change is that with respect to the zone 1, 2 or zone 3 and 4, the temperature, rail temperature range is changing, and that is where the decisions has to be taken. Now, coming to the gap survey, the gap survey means we are talking about a gap which is available in between the two rails which are being welded or going to be welded. So, it is required at locations where the track develops excessive creep or jammed joints or sun kinks or wide gaps, misalignment, battered and hogged rails or fractures at the joints or bending of the bolts. So, what we are talking in all of these cases is there is some sort of a distress which has got induced in the track. So, if we are talking about a rail section and the delta T is positive here, so there is going to be a movement of this rail. And when this movement happens and there is another rail which is being placed here and these two are being jointed together, maybe either by a fish plate and the fish bolts and nuts or as a welded condition. So, here in the case of if it is being provided with a fish plate and the fish bolt, this rail end will also be moving because of this temperature of delta T. And if both of these moves, there is a possibility that it comes to a condition like this, and then there is going to be a jam condition of this joint. If it is a negative delta T and the movement is in the backward direction, then this joint will open up. So, there are two things which may happen in this form. Along with that, because of these gaps, because of the condition of the track, supporting structure as well as the rails and the wheel loads which are coming at the top, and the running of the wheels or the stopping or the braking of the wheels, there are always a possibility of the battering of the rail lands, and this we have discussed previously again and again. So, in all of these cases it is required to go for a gap survey. So, whether the gap is being left or the gap is reduced or the gap has increased or there is a jamming condition, that has to be reported. And this gap survey, it is conducted once in a year before the end of February on a clear and sunny day in cool hours with rising rail temperature trend. So, in the morning if you start and you continue it to this work in the daytime, then obviously the temperatures will be continuously increasing, and that is where we will be getting some value. So, here how we do that is that this temper gauge is there. So, this temper gauge, as you can see, it is a tapered system. This tapered gauge means here it is 25 mm and at the end on this side is 1 mm. So, we insert it in that joint or the gap where it has come and try to examine whether it is 1 mm or 5 mm or 10 mm or 12 mm, whatever the value is there, that will come by itself. It has a thickness of 6 mm as such and at a length of 240 mm. So, this type of a taper gauge is being used. Now, conversion of SWR into LWR. So, we did talk about it that if you are going for a ballast section, then if the heavy rail sections have been used, say 60 kg per meter has been used, then in that case it is better that we provide that ballast section with the specifications of LWR track. So, this is the conversion which we are looking here. What are the precautions which needs to be taken when we are converting a gauge from the rail section from SWR to LWR? The anticipated residual life shall be at least 10 years. That means the new maintenance requirement should not come before 10 years. At least for 10 years the track should work, it should get operated, there should not be any problem. Ultrasonic test, USFD has to be done, and all defective rails, they shall be replaced before the conversion is done. We did talk about those things that can be a corrosion, there can be flaws, there can be some other defects or wears, or there can be internal cracks in the rail sections. So, everything has to be detected, and if it is being observed, then it has to be replaced. It should not be used when we are going for a conversion. Then rail ends which are hogged or battered, or the rail ends which are having a history of cracks in the bolt hole region because of the excessive stresses which are coming at that point, they shall be cropped before the conversion into LWR. And we did talk about this. We said that if there is a rail section, it is to be jointed, but then it has holes in it because the fish plated joint has been there previously. So, we talked about that there should be a cropping of this particular section, and if because of some reason the cropping is not being done, then the distance of the hole, the first hole from the rail end shall be more than 40 mm. So, these are the things which we have discussed previously. So, you need to remember such type of limits of time of permissible conditions which are already discussed. Then maintenance of SWR. Now, regular track maintenance operations like packing, lifting, aligning, local adjustments on the curves, screening of ballast, because the ballast over the years it has been taking the loads, it has maybe broken, or there has been more of fines being produced because of abrasion or attritions, whatever is taking up. So, screening of ballast may be required. Other than the deep screening, we are not talking about the total material being taken up and then done it. A scattered renewal of the sleepers at only those locations where 1 or 2 sleepers have been found that they needs to be changed, so it can be done. These may be carried out without restrictions when the rail temperature is below Tm plus 25 degree centigrade in the case of zone 1 and 2, and Tm plus 20 degree centigrade in the case of zone 3 and 4. And Tm I have already specified that it is an average mean temperature of the rail sections and it is being considered over the years. So, this is one range which is there, which needs to be considered when we are talking about these regular maintenance operations. Now, in the case on curves of less than 875 meter radius on the broad gauge, or if there is a formation which is yielding in nature, then in those cases the above temperature limits for zone 1 and 2 and zone 3 and 4, they may be revised as Tm plus 15 degree centigrade and Tm plus 10 degree centigrade instead of 25 and 20 degree centigrade respectively for the 2 zone categories. Now, coming to the maintenance of SWR, if the temperature is higher than the specified values, then not more than 30 sleeper spaces in one continuous stress shall be opened. So, that means that is a limit. At the one particular time only 30 sleepers shall be taken out. They should be opened, and before the end of the day it should be ensured that the ballast is being boxed up, means every work is being done. But if there is a requirement of a major lifting or a major alignment of track, or there is a requirement of a deep screening or renewal of sleepers, in that case again, as we discussed previously, the temperature of Tm plus 15 or Tm plus 10 degree centigrade is to be considered for zone 1 and 2 and 3 and 4 respectively. Then in the case of fracture in the weld or in rail, the portion of rail with fracture is cut and is removed for a length not less than 5.5 meter to carry out the rewelding, duly introducing a rail piece of equivalent length. So, we cut a length of 5.5 meter and more, and of the same size we are putting a rail section here, which is a better rail section, and rewelding is going to be done. And we also ensure that no weld lies closer than 4 meter from the fish plated joint. So, it means they should not come very near. There is a weld joint and then there is a fish plated joint. If they come very near to each other, that is not advisable. So, that limit is being defined in terms of 4 meter. Now, there are some do's and don'ts for the staff maintaining the SWR. First of all, treat SWR as important as LWR. Ensure correct gaps in the fish plated joints. Conduct gap survey as we discussed using the taper gauge. Ballast cushion shall be maintained, and if there are any deficiencies, then screening etc. should be done to remove those deficiencies. Provide additional shoulder width of 100 mm on outside the curves, and again that was discussed, that is 100 or 150 mm depending on whether we are talking about the sharper curves or those. Provide adequate number of joggled fish plates and the special clamps to the gang which is moving to check the track, and as soon as they found there is a problem, they should be able to change that. Ensure that not two welds lie closer than 4 meter and not no weld is closer than 4 meter from the joint after rectification. So, this is also important. Then convert the 5 rail panels into 2.5 rail panels. Subjective, there is a problem and we have not been able to solve the problem, or otherwise it is better that we change SWR into LWR. And carry thermometer to measure the rail temperature during inspection, and that record has to be done. So, this is also an important aspect for the staff which is moving to check the SWR. Talking about the don'ts, the deficiency of any fastening or fitting shall not be left unattended. So, it should not be left unattended. It has to be taken care of as early as possible. In the case of curves where the radius is less than 875 meters, in the case of broad gauge, or we also talked about the yielding formations, the continuous maintenance shall not be done if the rail temperature reaches Tm plus 20 in the case of 1 and 2 and Tm plus 10 in the case of 3 and 4. If the rail temperature has reached this, then we have to stop our maintenance work and we have to wait. And in above cases, do not open more than 30 sleepers at a time. This we already said. If a rail temperature limit is reached, then do not carry out major lifting, major track alignment, deep screening etc., and not more than 2 consecutive joints shall get jammed at any point of a time. So, one joint and the other joint, they should not come and they should not get jammed. So, these are the don'ts for the staff maintaining the SWR. They have to take care of all of these things. With this, we close our discussion now. What we have discussed about the short welded rails, their definitions, requirements with respect to the various components of the track, the laying of the SWR, the gap surveys, various tolerances related to that, the maintenance, and the do's and don'ts for the maintenance staff. Thank you. We will be meeting in the next lecture after.